Hello, hello, and welcome to a little video about modeling linear inequalities. Let's get started with the warm-up. The first thing that I'd like to do is just solve a regular equation. This one we solve by subtracting 1 from both sides. Beautiful. Let's take a look now at inequalities because essentially we're doing the same thing, we just have symbols. So I'm going to draw a line down the symbol. To solve this, I'm going to solve it like an equation by adding 2 to both sides. We have an x left on the left side. The symbol stays the same. 5 plus 2 is 7. We read this as x is greater than 7 because x is on the open end of the inequality symbol. Number 3. In number 3, we have x over 3, which is x divided by 3, is less than or equal to negative 1. We'll solve it like we always solve division problems, by multiplying. So we've got x is less than or equal to negative 3. Now the fourth warm-up I have here pertains to this special rule. If you multiply or divide both sides of an inequality by a negative number, then you need to reverse the inequality symbol. So for number 4, I'm going to rewrite it. Negative x is actually negative 1x is greater than 4. Now, we are going to have to divide both sides by negative 1 in order to get x by itself. Since I'm dividing by a negative number, my symbol must flip. I do that immediately so that I don't forget. So we've got x is less than negative 4. X is on the pointy end. That's why it's less than. Oh, and I forgot to mention this less than or equal to. If there's a line underneath, think of it as stealing a line from an equal sign. So it's or equal to as well. Okay, next. What I'd like to do in these two problems is just write an inequality modeling these problems. So we're not going to solve it, we're just going to write it. Adrian has $200 saved, and he already spent $25. He plans to spend $5 on a Starbucks drink every week. Let's write an inequality. All right. Well, Adrian starts off with $200. Can he spend more than that? No. So whatever we write must be less than 200. Less than. Can he spend exactly $200? Why not? Or equal to. All right. Now, he's already spent 25, so I'm just going to write that to 25 because we can't change it. He's spent it. It's gone. And plus, he plans to spend $5 on a Starbucks drink every week. $5, and I'll write X for Starbucks drink. Doesn't really matter what letter we use. You could use the letter S, but my S's will look like 5s. All right, let's take a look at Vivian. Vivian wants to buy tons of Air Jordans. Apparently she's made of money. She worked all summer and saved $650. She already spent $145 and plans to spend $150 on a pair of shoes every month. Let's write an inequality. First, Vivian saved $650. Can she spend more than $650? No. So whatever else we write must be less than $650. Can she spend all of her money? Why the heck not? Now, she's already spent $145. We can't change that. So we're just going to write down that number. It's spent. She also plans, plus $150 for every month, for every shoe. So $150x for $150 every month. So $150 every month. There we go. Now let's practice solving them. All right, so when we solve inequalities, we not only have to write down the answer, but we have to graph the answer. Because inequalities don't just say x can be a specific number, it says x can be a load of different numbers. All right, number 3. We have 3/2 x is greater than 4. Now the way we dealt with fractions in equations is we multiplied both sides by its reciprocal, by 2 over 3. On the left side, the 2's cancel, the 3's cancel. I'm left with x. I multiplied by a positive fraction, so my symbol stays the same. And then in my calculator, 4 times 2 is 8 divided by 3. Or, of course, you can write in 4 times 2 over 3 just in our awesome fancy new calculators. And we get 2.7. X is greater than 2.7. When we have a symbol like this or this, we have to use an open circle on whatever number it is. So let's find 2.7. I'm assuming it's right here. X is greater than. I'm going to draw an arrow from that dot to the right, because greater, the numbers get bigger to the right. Number 4, another fraction, but this time it's negative. Let's see what happens. On a blue line. There we go. All right, I'm going to multiply both sides by negative 3 over 2. On the left side, everything cancels, the negatives, the 2's, the 3's, x. I multiplied by a negative fraction, I gotta flip my symbol. 4 times negative 3 over 2 is negative 6. And again, you put that into your calculator. X is greater than or equal to negative 6. Now, when we have a greater than or equal to or less than or equal to, we draw a filled-in dot on our number line. All right? So I find negative 6, filled-in dot, and x is greater than, because it's on the open end, my arrow points to the right. Number 5, a 2-step. We could do this. Line down the middle. Why aren't you blue? Like, he's doing that. That's so rude. There we go. Now, the first step I'm going to take here is to add 7 to both sides. Fantastic. These 7's cancel. I'm left with 6. X is less than or equal to 12. To finish this problem, I divide both sides by 6. I'm dividing by a positive number, so my symbol doesn't change. X is less than or equal to 2. Whoops, what did I just do? I think I zoomed out too much. That's fine. All right, so we're going to find 2. We're going to put a solid dot on it. Less is left. That's actually how I remember which way greater than is. I think to myself, less is left. Oh, that means I go to the right for greater and to the left for less. Fantastic. Number 6. I'm telling you, I select blue and it draws black. Rude. All right, let's start with subtracting 5 from both sides. Bloop. So we have 13. Yeah, 13 is less than 3x. Then we divide both sides by 3. 13 over 3 is 4.3. Is less than x. So if I'm reading it from the side of the x, x is greater than 4.3. Okay. Let's draw it. 4.3 is somewhere here. Open circle, because it's just less than, or sorry, greater than. And then x goes to the right. Open arrow to the right. Or open side of the... Can we start that sentence over? Yes, we can. Thank you, Miss Gumin. When your letter is on the open side of the symbol, your arrow goes to the right. It's greater than. And at the end, I'll draw how I kind of imagine it in my head. Okay, number 7. Let's solve it. Line down the middle. Let's start with subtracting 7. 3 is less than negative 2x. Ooh, a negative. We're going to divide both sides by negative 2. Since we divided by a negative, flip our symbol. Do that immediately. We have x on the right and negative 1.5 on the left. So x is less than negative 1.5. So I'm going to put an open circle on negative 1.5 and draw an arrow to the left. Lastly, let's take a look at number 8. Ooh, we got x's on both sides. That's a funky one. But you know what? It's no different than equations that we've been solving like this. I'm going to start off with, I'm going to subtract 12 from both sides, 12x, because I feel like it this time. All right, 5x minus 12x is negative 7x, plus 4 is less than negative 10. Next, I'm going to subtract 4 from both sides. Negative 7x is less than negative 14. And I'm about to divide by a negative, which means my symbol must flip. Let's do that. Flip. X on this side, 2 on that side. Okay, let's graph it. X is greater than 2. Open circle on 2, arrow to the right. Now, I know when you were in elementary school, teachers taught you many different ways to think about the inequality symbol. This is how I thought about it, or I was taught. Here's our inequality symbol. Here's some teeth. And here is an alligator. Such a scary little alligator. It likes to eat big things. So anything here, anything on the open end of its mouth, this mouth, is greater than. Anything on the small end is less than. So when number 8, x is on the open end of the mouth, it's greater. Number 7, x is on the other side. It's on the closed end of the mouth, so it's less. That's kind of how I think about it. That is such a cute alligator. I am proud of that alligator. Anyways, I hope you have a wonderful rest of whatever day it is for you, and I hope this helped. Bye!